Hello students. Previously we have discussed the transistor symbols and transistor history and transistor terminals. What is the difference between diode and transistor? Okay, we'll see today the actual transistor, physical transistor. So these are the different transistors we have. So a transistor will be having a three-terminal electronic device made of semiconductor material. Transistor have So here the transistor have many uses, including amplification, which are done in active region, switching, okay, switching and regulation, all this will be what in power electronic converters, and modulation, this is in communication, okay. So this is what you can see, the transistor physical device, having emitter, base and collector, three-terminal device, different transistor for different applications. So basically, transistor will be either will be having a construction based on silicon or germanium. Silicon or germanium will be fourth group elements containing three separate regions. As you can see, emitter, collector and base. As I said, emitter is highly doped, collector is moderately doped, and base is lightly doped. Okay, as I said, this is arrow leaving from the emitter. Arrow leaving from the emitter is nothing but PNP. PNP is nothing but two diodes sandwiched. Two diodes are sandwiched over one region. So this is what PN diode, this is NP diode. So one diode, if you are having one diode, you will be having one junction. If you are having two diodes, then definitely you will be having two junctions. So a transistor is a two diodes sandwiched. No, two diodes sandwiched. Then you get two junctions. So that is nothing but transistor will be having two junctions. Transistor will be having two junctions. Across this one junction, this is emitter junction. The other is what? Collector junction. Emitter and collector junction. Two diodes, two junctions. This is nothing but PNP transistor. Okay, and this is arrow, emitter, collector and base. Arrow is hitting towards to the emitter. This is called NPN transistor. Okay, the architecture or the construction of BJT is nothing but, as you have seen, PNP. If I exactly cut in cross view like this, okay, like this, it is having two diodes. One is PN, the other is ENP diode. Two diodes. If you draw a symbol like this, PN, and this is what? NP. Am I correct? So this will be what? Collector. This will be what? Emitter. And exactly we have here base. Hope you understood now. So as I said, BJT will be having constructed with three doped semiconductor regions, emitter, base, collector, separated by two PN junctions. Two PN junctions means two diodes, two junctions. So the regions are, those three regions are emitter, base, collector, are the different semiconductor regions. How many junctions are there? We have emitter junction and collector junction. You can see here, this is what basic epitaxial planar structure of a transistor transistor where we have emitter, base and collector. Okay, or a metal oxide, metallized contacts. Hope you understand this point. So BJT, depletion regions do not have the same width because different regions have different doping levels. For example, if you observe here, this is what the emitter junction. Emitter junction will be what? This one. Okay. In the same way, let me change the ink here. So this is what the base junction and this is what the collector junction. Okay. Collector junction. If you observe these points, emitter, base and collector. Due to this, you can also see a depletion region here. So this is what, if you take this is the complete width of the base. If you take this as a complete width, depletion region will depletion layer depends upon the biasing with which we are biasing the junctions. Okay. Based on that, we have different input output characteristics for different regions, different biasing techniques. Okay. So if you have connected this, for example, let us consider a voltage here. Let me take here N, P, N, N, P, N. If I connect N to negative and P to positive, then it becomes a forward bias. Forward bias. That is, junction JE is forward bias. In the same way, if I connect this in reverse bias. Reverse bias means connecting to the opposite terminals. Negative region connected to positive terminal and the positive region is connected to negative terminal of the battery. This is what? This voltage is nothing but connected between emitter and base. This voltage is connected between collector and base. Then this junction will be in reverse bias. Collector junction is in reverse bias. Hope you understand. There are, for example, if you understand, for one diode, we have one junction. Yes, for one junction, how many different biasing techniques we have? We have forward bias, we have reverse bias. Okay, for one, there are two combinations. If there are two diodes, then how many combinations we get here? 4 combinations. Am I correct? Maybe either forward forward, forward reverse, reverse forward, reverse reverse. Based on these, transistor will work. Transistor region. Okay. So as I said, transistor biasing will be this.